smart grid technologies. So when we are talking about fundamentals, before we know about the fundamental of the smart grid technologies, we need to understand what is smart grid technology. And before we go into what is smart grid technology, we need to understand what is a grid, what we are talking about, what is a grid. So when we talk about a grid, basically in a traditional term, we called it a power grid. So this is the current scenario or the traditional approach where we receive the electricity at our home or at our office, which is coming from the power station through various stages from various elements which are connected in that series. So, and they are all interconnected. So basically the power grid is the thing which is interconnected of various power system elements, which comprises of starting from the power station, then there is transformer, then through the transmission lines, we receive the power through transmission substations, distribution substations, and so on. So that's how the electricity comes to our home. But this electricity, when we receive it, it comes from very, very far place, meaning that power station is not close to your home or your office. So that is a traditional approach that we are today receiving the electricity or power in our home. And this electricity is, of course, transmitted through the long transmission lines. So what could be done here that we think that it can turn the power grid term can be turned into smart grid? That is the thing that we are talking about, smart grid technology. So the system remains the same, but we turn it into a smart way. So when the term smart comes, then many smart things come in between, which make it a smart system. So before we understand what is that smart system, I want you to have a look at this short clip and to understand, try to understand and see whether you find out, what do you find out from this, that whether it is a myth or it's a reality. You think that it is possible, or we are just talking in the air, we are just dreaming it. So I want all of you to have a look at this very short, very short video of, I think, 1 minute.
The world of energy is changing. Change is good. It creates new opportunities. As long as we can adapt, the potential is endless. But in the world of energy, change can be difficult.
So what it is talking about over here, that the change is difficult. So when we say change is difficult, when we say that
in the world of energy, change can be difficult.
So when we say that the change is difficult, what does it mean? Do you think that it is really difficult or it is possible? I want to see the chat box. Probably, I'm sure everybody can send the messages through the chat box. So I want to see what is the public opinion, what the participants they think about that, that it is really something difficult to convert the power grid, the existing system into a smart way, that is quite difficult, or it is easy. So my question is a myth or reality. So probably I need to go into chat box. I'm not sure if participants can send the chat message or not, but I believe there is a Q&A box as well. So tell me about your understanding. What do you think? What we can, how we can understand this, that it can be transformed, if this change can happen, but is it practical? So this is my question. So I will hold to my this question and I will move to the definition. The definition. Okay, I think my slides are stuck somewhere. Okay, now it's okay. Okay, so I will hold to this question and I will let all of you think about it, and I'm just shoot your answers in the chat box, which I will read later on. Tell me about that, that you are what you are understanding side by side. Is it really a myth or it's a reality? So let's have a look. What is a smart grid? National Institute of Standards and Technology, which is in short NIST from USA, they say that what is smart grid? It's a modernized grid. So basically the existing grid, they are calling it a modernized grid, which has a bi-directional flow of energy. In the previous system that you have seen, the traditional approach, there is only one way communication. You are receiving power from power station, but there is no way that there is something reverse way approach or reverse communication. So that is a bi-directional flow of energy. Now, what it has, it uses two-way communication and control capabilities. Not only communication, also the control capabilities, which led to an array of new functionalities and applications. So different applications, they are connected in the form of array with this modernized grid that we are referring to as smart grid. Now, let's have a look what IEEE says about smart grid. As if you have noticed earlier, IEEE has one technical community on IEEE smart grid. They are the focused group who is focusing on the development in the doing the research and development in the field of smart grid. So IEEE says that it's a revolutionary undertaking. So why they are calling it revolutionary? Because if you remember from my 2 slides back, I was talking about a myth. So a myth and the change, all these things are connected with revolution. So why revolutionary thing? So their definition says that it's a revolutionary undertaking which is comprises of new communication and control capabilities, energy sources generation models, and the most importantly, adherence to cross-jurisdictional regulatory structure. So this is the most important point that IEEE highlights when they talk about IEEE Smart Grid, the cross-jurisdictional regulatory structure, which in the definition of NIST, you have listened to this, the array of new functionalities and applications. So understanding these two definitions and then the concept that I am explaining, I have put it here, smart grid in a very easy way, in a simple word. In order to understand that, just focus on these few points and you will get the clear idea what is smart grid. Basically, smart grid is the electricity network, okay, that we already have it in the power grid as well. But what is the difference? The difference is digital technology. So it uses digital technology, and most importantly, what it does two-way communication from the power generation sources until the consumer. So it supply electricity to consumers in a two-way digital communication way for more efficient distribution. So when we talk about more efficient distribution, what does it mean? When you centralize the system, when you make the communication is happening, then you make things efficient when it is two-way communication. So another simple point is that what does it do? It provides monitoring, control, communication. So in the traditional way, in the power grid, you cannot find this control and communication in a two-way. All these things are present, monitoring, control, and communication, but they are not available in a two-way communication mode. And then analysis of all these data in a supply chain way. So that's the business term, supply chain. So what is that? That you have all the data which is coming through two-way communication, that you can analyze this from your digital network. Now, what is the purpose? Why we are using this? What is the aim of using smart grid? So basically, the aim of using smart grid is to reduce the energy cost. Now, you will ask me why and how I'm talking about it reduces the energy cost, and then as well as consumption. Originally, I'm coming from Pakistan, and we have a lot of shortfall of electricity. I'm not sure about India, but your other neighboring country, Bangladesh, they have been also suffering in the past, but now things are a bit better. In Pakistan, people have been suffering with this energy consumption issues because there are a lot of wastage of electricity. So when you talk about smart grid system, there you will have an efficient way which will reduce your cost, which you will see in my upcoming slide, how it is affecting the cost side and then the consumption side. Also, what it is there, another thing is to improve the reliability and transparency of energy supply. Okay, when we have the components, because I'm not going to talk about components now, so that's why I'm just using the term smart components. So when you have smart components in your grid system, which makes it a smart grid, basically you have the reliability of all the data and transparency. Everything you can see it clearly, you can visualize it, you can find out in terms of statistical data and so on, which helps you to improve the reliability, and it helps you achieve the main goal, which is to reduce the energy cost. You will see in upcoming slides when step by step things are coming. Now, what this system is used for. This is the most interesting thing, that this system is developed to overcome the weaknesses or the loopholes of the conventional electric grid or the power grid that we have been using. What it is that transparency issues, electricity theft, losses due to the long due to the long transmission lines, and then there is no such kind of efficient energy cost system which can help you to deal with the electricity companies to save money on your electric consumption. So overall, this whole system is basically made to overcome on the weaknesses of our traditional power grid. That is the purpose of smart grid. So I'm sure that all of you have gotten this idea what exactly the smart grid is. Now, let's move to the next level. What IEEE says, if if the successful rollout of smart grid happens, what will happen? What type of things will happen? So what type of domains? What are the domains? What are the areas which smart grid can cover it up? So IEEE still refer to it. It's a phenomenal array of discipline. Why phenomenal? You will understand that because of the concept that we are talking about. In the successful rollout time, this is a phenomenal array. Why array? Because everything is interconnected in this system. What it is interconnected? Starting from generation until the consumer, everything is interconnected. That is the beauty of smart grid technology, where everything has a two-way communication and they are all connected. So it covers generation, transmission, distribution, customers or consumers, operations, markets, and service providers. They are all in that array, the so-called phenomenal array of all the technologies or all the components of smart grid that makes it the overall the smart grid domain. So now these are all the areas where every single component or every single area can be elevated to the smart level, and then it can contribute to the overall system of smart grid. So it's not only about generation, it's not only about transmission, it's not only at the consumer end. But yes, again, my question, do you think it is a myth or it's a reality? This is the thing that I'm keep on asking, and you ask yourself after understanding all these things, that is it really possible that we change the whole system from generation level until the consumer end, and then everything come forward in a digital way? So let's have a look at my next slide and hold your answers. Now, what are the technologies in smart grid? So when we talk about smart grid, you have understood the basics, you have understood what are the domains, you have understood what are the areas. Now, what type of technologies you can use which can make the overall grid system as the smart grid? So when we talk about this, the same, it is the electric network, but what does it do? It uses advanced digital communication network. The old communication network, the analog based or the old long transmission things, everything, now they are turned into digital communication network. For what purpose? To provide better power distribution. So that is the simple objective, simple aim to get it from smart grid technologies. And then, interestingly, to have the easy control on everything. So here I have jotted down a few of the smart grid technologies, which are some of them are already at higher maturity level in the market, but some of them they are still coming up, and then there are more. So as I mentioned earlier, that this topic is a very big. We cannot cover it up in 1 hour. So I am just touching and giving you an appetizer so that you have an idea about smart grid technologies, and especially to those undergraduate students and postgraduates who are thinking or aiming for their future. You see, based on your interest, where your future is or where you are looking forward to grow your career. So among smart grid technologies, the first thing is intelligent appliances. So what is intelligent appliances? You may have heard of smart homes. In that everything is smart. What is smart? So whenever you hear the word smart, there is something smart coming, that there is something digital. Okay, digital communication is involved, and you can control them through your mobile phone or your devices, and you can control them from them. So from your devices you are controlling, or maybe from your web browser and so on. So that is intelligent appliances. Or maybe your television, your fridge, your washing machine, they are connected through IoT. So that is also among the intelligent appliances. So this is one area which is one of the component of smart grid technology. Second one, smart meters. This is already in the market, quite mature, but still in the way further, there is further room of improvement, which researchers are already working, and companies, the transmission and distribution companies, they are looking forward to further grow on that. So smart meters, your existing meters, which you had it, the energy meters outside your home or your building, which were recording your all the electricity consumption, replace them with a smart meter. So in that smart meter, different technology, different versions are already in the market. So what happened with that smart meter, that you can observe your overall energy consumption. So when you can observe, not only you as a consumer can observe, you can also manage, you can also plan how you want to utilize your electricity. And then when it comes to the service provider can also control the theft of electricity by obtaining the data from the meters, without sending a meter reader which goes and record the readings. And we all know, you also know, I also know that how the meter readers, they do the theft and so on. Not all, but I mean, this is one of the sites that the electricity theft happen from there. And then another interesting thing, what I mentioned, that you can observe and control your electricity usage. So later I will show Malaysia example, but I will just mention here that in Malaysia we have this application of electricity department. Everybody can download and then can observe their meter in almost real time, that you can find out how much you have consumed today and in the whole month, and so on. Accordingly, you can plan your overall electricity usage. So how this is happening? It's happening using smart meters. Then next comes smart substation. So we all know that substations, power stations. So in those substations, we are still using the old system, the old analog meters, and the readings are happening all manually. There is no such system that the meters reading, that we do it automatically, or we control it centralized, where we get all the data coming to one center, that which can observe real time what is happening. That is still manual. So this is something that substations to be improved with the digital devices, or those such components can be introduced there, or such devices can be introduced which can make it smart and efficient, where their communication becomes digital. Now, instead of using the casual usual cables that are used in the substations, power stations, they can be changed into superconducting cables, which will make the overall system efficient. And then the last but not the least, integrated communication. So this is the thing that we are talking about for all these appliances, meters, substation, this and that. They need to be all integrated in a array. So that is all about smart grid technology. And many things can be added to this, but these are the main things which are practically happening right now, and further development is going on among them. Now here I would like to show one video. This is from Smart Grid from USA. They are in this video, they are showing the whole concept of smart grid that I have explained through the definitions and in my explanation. You will see here visually where you will see that what are the things that can be covered up within smart grid and where there are still we have the room for improvement. So let's have a look at this video. It's a quite short video, not so long, probably I think 3 minutes. So let's have a look.
The current electric grid was conceived more than 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demand, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener. The smart grid enables newer technologies to be integrated, such as wind and solar energy production and plug-in electric vehicle charging. Our participation as informed consumers, the smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with us to help manage our electricity needs. The smart home communicates with the grid and enables consumers to manage their electricity usage. By measuring a home's electricity consumption more frequently through a smart meter, utilities can provide their customer with much better information to manage their electricity bills. Inside the smart home, a home area network, or HON, connects smart appliances, thermostats, and other electric devices to an energy management system. Smart appliances and devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills. These smart devices can be controlled and scheduled over the web or
here I want to explain this concept that you have seen about the okay, let me bring it here. So you saw here it is talking about washing machine at 9 a.m. and other things at certain time frame. Basically what it is, this is a system in developed countries where they do not have electricity tariff throughout the day, a same tariff. Like in Malaysia, we have the same tariff. You use electricity in the morning or you use in the evening, you will pay the same bill. But in developed countries, they have a different tariff of peak hours and peak hours. So what happened that in order to balance the load, they have come up with this idea of off-peak and peak charges. So they tell people to do not, they do not encourage them to use their appliances in the peak hours. So you use most of the appliances which can be done in the off-peak hours so that you pay the less bill and then the electricity shortfall doesn't happen in the peak hours. So that is how the smart appliances in smart homes are needed for to contribute to smart grid technologies.
Devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills. These smart devices can be controlled and scheduled over the web or even a TV. Renewable resources, such as wind and solar, are a sustainable and growing source for electric power. However, renewable power sources are variable by nature, add complexity to normal grid operations. The smart grid provides the data and automation needed to enable solar panels and wind farms to put energy onto the grid and optimize its use. To keep up with constantly changing energy demands, utilities must turn power off depending on the amount of power needed at certain times of the day. The cost to deliver power depends on the time of day it is used. Electricity is more costly to deliver at peak times because additional, often less efficient power plants must be run to meet the higher demand. The smart grid will enable utilities to manage and moderate electricity usage with the cooperation of their customers, especially during peak demand times. As a result, utilities will be able to reduce their operating costs. By deferring electricity usage away from peak hours and having appliances and devices run at other times, electricity production is more evenly distributed throughout the day. The power being used right now was generated less than a second ago many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity production, reducing the need to fire up secondary power plants. The distribution system route.
So you see, when you have smart appliances or smart grid technologies at your home as well at the consumer end, it will also help, it will also reduce the burden from the power grids, as well as the consumers get the benefit in terms of getting the cheaper electricity. So this is
power from the utility to residential and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any break in this system caused by storms, bad weather, or sudden changes in electricity demand can lead to outages. The smart grid's distribution intelligence counters these energy fluctuations and outages by automatically identifying problems and rerouting and restoring power delivery.
So, when we have this system, in this system, we are actually decentralizing our grid operation. So what does this mean, decentralizing? Right now, the system which is existing in most of the countries around the world is the centralized system, that there is a national grid, national power station, national everything, and they are the one which is providing the supply. We don't have any integration system where we have the renewable energy sources or other energy sources which are integrated with the grid. So that makes the overall system complex. And what happened that at one point, if you have a breakdown and the whole system is down, because why? They have to send their man physically, they go, they have to locate where the fault has happened, and then they have to troubleshoot. And because of that, the consumer, they suffer sometimes maybe for 2 days, 3 days, there is no electricity in some of the areas. This happens. So when you will have a decentralized system, what will happen? Decentralized plus it is connected through digital communication with a two-way communication. So the equipment will itself inform that this has happened with me and the breakdown is happening at this point. Then the decentralized grid stations, they will have the opportunity, whichever is the nearby grid station, to reroute the load. And what will happen that you will have a least time to restore back the shortfalls, restore back the energy cutoffs. So these are some of the advantages that I have shown you in the form of video, but let's have a look on some of the advantages over here. Basically, I categorize this smart grid technologies into three things, or you can say that these are the three motives. One is that to digitalize the whole system, to decentralize the whole system in order to get decarbonization. So what decarbonization? We are now suffering with climate change issues. Okay. So when we do not have a sustainable sources of energy around us, so we have to look forward for decarbonization as well. So these three D's, the digitalization, decentralization, and decarbonizations, these are the pillars of smart grid technologies. Now, what are generally the advantages of smart grid technology is to provide more reliable power. You get more efficient renewable power as well. For example, if there is some area which has a suitable environment for wind energy, so windmills can be planted there, and then the supply can be given to that particular area through that renewable source. Or maybe solar power plants could be solar panels could be planted into those areas where there is high sun available. So what will happen that you will generate free electricity through those solar panels that you are investing for one time only for up to 25 years of benefits. So you get the electricity in a more efficient renewable power generation mix. And then you will have a mixed source of energy. So this one I have talked already. You have solar, wind energy, nuclear energy, and other sources of energy. And then you will provide this to fulfill the need of the people in your area. Now, everything is working with smart devices and smart homes. This is the advantage. And then you will reduce the equipment failure. This one I have explained the example how you can reduce the equipment failure time and then the equipment failure as well. When the system doesn't go overload, of course, you are reducing the equipment failure. Now, ultimately, it will affect to reduce the electricity cost and then the meter costs as well. Okay, and then the electricity losses, of course, they will be less. The chances of blackout will be reduced, and carbon footprints, you will reduce them as well when you have a decentralized system. And then it will also open up the avenues for electric vehicles. So electric vehicles are coming up. This is the new generation thing. In this coming generation time, electric vehicles are something that are coming very soon. In most of the countries, they have already touched the ground at the testing levels. But some companies, they are already moving forward, the automobile companies, to electric vehicles. So that is the future. So when you will have electric vehicles, imagine that you need more power. How you are going to supply them if you will not have alternative sources of energy? If we will rely on our conventional system, definitely the whole system will be collapsed. And this is one of the challenge for developing countries, that we are not easy to achieve the goals of smart technologies whatsoever it is. And then interestingly for students, you will get the job opportunities. What job opportunities? The smart job opportunities. So nowadays students, they are studying all smart technologies, they are studying programming, they are studying data analytics, this and that and that. So all these jobs will be waiting for you in the market. So these are the advantages, and there are many others beyond this in smart grid technologies. Now, when we are talking about advantages, it's not that straightforward. Advantages to change the overall system, yes, it looks very nice, that a revolutionary, if you remember the word revolutionary phenomena. So yes, that revolution will bring the advantages for us, but what are the disadvantages, or what are the limitations that we may face or we will have when we are moving forward to this technology in 100% implementation? The first thing, it will incur the high cost. So for what? To replace all the analog meters, the existing system with the sophisticated electronic meters or the smart meters. And then also we are short of, or we are lack of regulatory norms at the government levels for this technology. So this is the general phenomena of all the governments. This is not only you or our government is having this issue, but this is because there are no standards available at this moment. Also, the official technology documentation is not yet fully matured. Then we need to have a stable network communication as well. So if we do not have a stable internet connection, of course, you cannot have a two-way communication in a proper way. So hence this system will be failed to communicate. And then it is quite dependent on weather as well. So network communication, when there is a heavy rain, there is a wind or storm or snow. So we have to think of these things as well wherever we are planting the smart grid technology. And most interesting, which is the biggest challenge even in any kind of communication, especially at government levels, that hacking. So this is one of the things that the hacking could affect the system, where the hackers, they can control the power meters and so on. So we need to have a secure system which can protect the overall functionality of the smart grid technologies. Okay, here I'm going to play this video. It's, I think, about 3 minutes. Yeah, about 3 minutes. This is about smart grid initiatives in Malaysia, which I want to show you that where Malaysia is standing right now. So what are the things in Malaysia? So please have a look at this video.
Digitalization, compensation. way our customers use energy has become increasingly complex. To reimagine the grid. To achieve this, PMB has embarked on smart grid initiatives to modernize the electric system and provide our customers with sustainable, flexible energy services. One smart grid initiative is to introduce advanced monitoring and control into the grid. Systems like our eyes in the network, where we can monitor and control the PMB is also involved in data analytics, gain insights with increasing wealth of data. Using the smart method, PMB is able to provide customer insights and offerings tailored to business needs. While in operations and maintenance activities, analytics is used to guide us on the most cost-efficient service to our customers. Facilitates customer efficiency various VR integration schemes via TMB.
So this is the app that I was talking about, that the consumers, they can analyze their consumption of electricity through this app. So it is covered in this video.
In addition, TMB also involves some battery storage pilots to offer VR connectivity in our network. Sustainability has become we've committed to replace our energy administration with higher renewable resources. Large-scale solar. The mobility space, we should expand the network. In addition, we also add to our fleet of electric vehicles because our to reduce carbon emissions. Right. To keep the power supply uninterrupted and data secure. TMB makes the cyber resiliency of its IT and OT system by complying with the required OT cybersecurity standards. It's in accordance with security hardening best practices globally.
So you have looked about what are the initiatives done in Malaysia. All these things are practically happening. So that's why I wanted to show that the reality part, the question that I have raised in the beginning, a myth or reality. So you see where Malaysia is moving forward in terms of reality towards the smart grid technologies. So many of the things that I have explained to you, they are almost initiated in Malaysia and they are practically happening. I will also mention that the smart grids are of course not available to everybody yet, but they are doing it in the stages. The new constructions or the new areas, they are receiving it first, and then slowly they are replacing, because you need to have a huge capital as well to replace the overall system. Now I'm going to show you next example, which is coming from Singapore. How they have made, they are calling it a first digital twin. So existing grid system, they have transformed it into the digital way. How they are making it, this is another approach of a small country, or you can say a city. So it's like a very small city. I'm sure many of you are aware how small it is. So you see what is their approach, where they have 11,000 substations all over their small country.
In Singapore, we enjoy one of the most reliable standards of electricity supply in the world. Behind this performance is a team of dedicated engineering and technical specialists. They oversee the running of over 11,000 substations, inspecting each one to ensure vital assets, such as transformers and switchgears, are able to efficiently transmit and distribute electrical supply across the island reliably.
Despite these best efforts, we must be prepared for any disruption. How can we better anticipate equipment failure, achieve higher precision in maintenance, and timely renewal of infrastructure and equipment? The answer lies in the digital twin of the grid. This is a virtual replica of the physical network and assets that can perform functions such as condition monitoring, analyzing asset health, and optimizing asset failure mitigation measures. The asset twin is a digital twin for grid assets. This is created through SP's in-house digital capabilities in software development and artificial intelligence, and our research and development collaboration with Nanyang Technological University. With the asset twin, we can create a one-stop integrated dashboard containing up-to-date information of all distribution assets of over 11,000 substations across our entire electricity network. Virtual 3D models of actual electrical assets are created to visualize assets in a substation. This helps to identify specific components that require attention. This delivers precise information to our field crew before they head to the substation. Sensors within the substation detect and alert signs of anomalies and deterioration. These sensors are additional eyes that monitor our assets around the clock. Issues can be identified and diagnosed remotely. With the digital twin of our assets, we're enhancing the performance of electricity assets in our network, upholding world-class grid reliability, and empowering the future of energy.
So you have seen here a perspective of Singapore, that what area they are focusing, since they have a small country but highly populated country, and they have to overcome on the upcoming energy crisis and so on. So how they are moving forward to digitalizing their whole system. So it's quite easy for a smaller country to do, but of course you need a lot of money. So I will not say that quite easy. I mean, it is practical when you have a small country, but still they have 11,000 substations which they have transformed and they are working on it. So that is another side of smart grid implementations that you can consider, or you can look into that for those, especially those who are towards the decision maker level. So they can see that yes, there is a possibility. So not only smart grid is about smart devices, smart homes, or smart meters, it is beyond that. So what is the main thing? To get the reliable energy and most efficient energy in a two-way digital communication. So since the time is quite short, I will very quickly just move from this. This one, I just touched one of the component, which is the sensing and measurement unit, that we called it smart metering concept. So why we use this? We want to reduce our electricity bills. We want to reduce the cost of our electricity consumption, and then we want to have we want to get rid of harmful carbon dioxide. So for this, we are moving forward to the smart technology. So in that, it's smart grid concept. What does it do? It's automatically do the meter reading thing. The whole system is an advanced metering infrastructure. And then what does it do? It automates the overall management of the metering system. So everything, you get it centralized in your hand through digital communication, and that I always refer that smartly. So what are its features? The smart grid features: the communication, the smart connectivity, disconnectivity, and reconnectivity. Also, it helps in protection from tampering the meters. You receive the stable voltage quality. You get your load profile in a nicer way, where you can manage it nicely to reduce your energy load. And then you can also cut your tariff rates by using or utilizing it in a smarter way during the off-peak hours, and reduce your usage during the peak hours. And then everybody need to have, of course, the government need to create energy awareness. If people don't know, they will not follow this. So in Malaysia, there are these initiatives going on, that the electricity company, they are making short videos and then they publish in their social media, where they are telling people, if you use your this particular one appliance in this way, you will save this much bill. So because people need to be aware. If they are not aware, of course they don't know. They cannot understand what is volt, ampere, wattage, this and that. But we can tell them, we can educate them in a layman term or in a layman way, which can help them in overcoming on these challenges together with us. So there are some upcoming technologies which are all, some of them are already in the market, which can be utilized or can be used at a domestic level. Even you don't have to wait for the government to implement. A few examples of this are like picowatt or Google Power Meter, where you can trace, if you don't have the smart meters and so on, you can make the your energy consumption tracking everything using digital devices at your home. So this is another approach of moving forward to the smarter way and to contribute to the country's smart grid initiative. You can connect these devices with your appliances, where you can optimize your usage and reduce the costing. So these are some of those examples. Some devices, they are already available in the market. So now, as a conclusion, what we are looking forward, we are looking forward a super smart grid, then a super smart grid. What is that super smart grid? One smart grid concept I have given you. Another super smart grid is where you can generate the electricity and you can also give to the excess energy, you can sell it to your grid station, and in return you get the money, or it is compensated to your electricity bill. So basically this is also part of smart grid, which comes when we are using renewable energy sources. So rather government have the load, or government have the the overall system, that government have to focus on energy generation. What we can have it, we, those who can afford, we plant the solar panels at our rooftops, we generate the electricity, the one we can use it, we use it, the rest extra we sell it to the national grid, or the smart grid. Basically this is not meant for national grid, meant for smart grid. So this is one of the things that we can do as a part that we can play. And if we cannot sell it, if our country or if our local government, they don't support this idea, we still can at least run for our own home, where we can reduce the burden from our governments, and this will be part of the smart grid. Now, using the smart grid technologies, what we can get it, we will not have the wastage. With the utilizing of electricity will be maximum, and then the technology can help us save the earth from global warming, that we are right now in a tough time of this challenge. And then we will have a modernized version before the governments or our energy supply companies they make it. We will get this system ahead of time. So that is what we all can contribute. So as my take home message to all the participants is, think smart and act smart. This is the thing. If you stick to this word of smart, you start thinking smart, how you can make the overall system efficient, and we start acting to make it efficient, we all can achieve the common goals which are for the humanity on our earth. So with this, I would like to say thank you very much. Here are my contact details. You can always visit my website, iamharoon.com.